When you and your teammates are trying to improve an AI system you're developing or maintaining, you want to be on the same page about what does progress mean and how you're going to evaluate those changes from this point onward, right? So we're going to walk through how to do that with Remix. We're going to edit a project that we created earlier and add context about what metrics we're tracking, set up an evaluation template and framework so that every new experiment that comes in gets measured the exact same way, and that way we can compare everything systematically. So we're going to start by navigating again to the Projects tab in the navbar. And we're going to edit the project we created earlier, which is the VQ-Asynth example here. Clicking this little gear button will allow us to see all the options about what other context we can add here and edit that. And there's plenty of things you can add in a project. Again, you can add all things about evaluation, as well as tying in other resources. As you can see, you can tie in linear or GitHub repos or other things here. But we're going to focus on the metrics component in the evaluation framework. So to start, for this VQ-Asynth project, we have particular metrics that we're interested in when we train a model based off of this data. We track certain metrics that help us understand how the data pipeline is progressing and improving over time. So I'm going to go ahead and click this Add Metric button, and I'm going to add a few of the metrics that we're interested here for this example. Okay, so I've added all the metrics that are relevant to us in this project in particular. Obviously, this will change depending on the context and project you're working on. But as an example, all I had to do was add a name and context about what this metric is measuring, and then establish a baseline. So what am I comparing everything to from this point onward? And this will change over time, obviously, as you establish new baselines as you're improving your project. So next up, let's set up an evaluation. So this will help us set up an eval template so that every new experiment gets measured the exact same way. If you don't already have an evaluation framework or script that you use in your project, you can generate one. But in this case, VQ-Asynth actually has a particular set of scripts that we use to help evaluate the models that get trained from the data that gets produced here. And I'll show you really quickly where that lives so that you can see in our example here. We can go ahead and find within Docker, we have an evaluation stage. And in this example, we have some scripts and a Docker file that we use in this project context to help evaluate how this pipeline is improving upon over time. And to show you a little bit in here, it has a custom script that we use to help run our evaluation process. So you can point to your own scripts or your own directory where you have multiple scripts or other things like environments like we have here, a Docker file, so that Remix can take that context in and be able to evaluate every new change in the exact same manner. So we're going to fill in this form in, and we're going to point to that particular directory that has a bunch of context we want to use so that every experiment gets measured with that particular script. Okay, so here is where we're going to add that eval script. So we're going to say it lives in Docker eval stage, and it will be able to get all the context of what scripts environments are in there to then produce the evaluation. And for this example, we also want to compare everything to this particular model baseline, which is what we use as the current state of where things are. This is a model that will be used in reference to the baseline. So in this part now, we're going to reference the same metrics that we had above. These are the metrics that this evaluation script that we created creates. So we're going to just add those in. Awesome. And if you wanted to add extra compute hints, so if you're plugging in Modal, for example, to help actually execute these evaluations, you can add little hints about what kind of resources are necessary to actually run this evaluation. For now, we'll keep that there, and we're going to save and lock this evaluation for ourselves. So now we have an eval framework that can be reused every time a new experiment gets evaluated. So whenever we propose a change and we want to evaluate, we will use this template to then run the script that was referenced in here, and then we'll be able to have this static asset that we can reference back. All right, let's move on to setting up a decision policy. So this helps everybody be on the same page about what constitutes progress, what means that this is a good condition to say we should move this experiment forward into maybe further online testing or be able to ship in some other way, or maybe this constitutes as a failure mode. This is something that we don't want to progress forward, or we want to be able to do a postmortem on to see why this particular thing failed. So we can set these conditions as well in here. So I'm going to fill these in now. So I'm going to add for my ship conditions, I'll say the spatial score delta should be greater than or equal to 0.2. And then we can add another one if we wanted to. So let's say we can also want to make sure that the omnispatial delta is also greater than or equal to as a possible change, and things that we might consider as a reject or being able to label it this way. We're going to say that the spatial score delta has to be less than 0.1, and let's say that we're going to add one more condition to say that an experiment is automatically rejected if we have the omnispatial delta also less than. All right. So if we save this policy, now everything will get basically considered in the exact same way. So we'll have a reference point when you go back on any experiment. Why did we label this with a ship? Why did we label this with a reject? And then what evaluation framework was used to evaluate how this particular experiment performed.